The internal architecture and flight trajectory of a ballistic missile represent a peak in aerospace engineering, designed to function across multiple environments from the Earth's surface to the vacuum of space. Structural components: re-entry vehicle, RV, and ablative heat shield. The re-entry vehicle is the protective, nose cone, that houses the payload. Because it re-enters the atmosphere from space at hypersonic speeds, it encounters extreme thermal stress caused by atmospheric friction. The ablative heat shield is a critical layer designed to slowly burn away or ablate, carrying heat away from the internal components to prevent the vehicle from disintegrating before it reaches its target. Guidance system, inertial navigation unit. Located just below the payload, the inertial navigation unit, INU, serves as the missile's brain. It uses high-precision gyroscopes and accelerometers to calculate the missile's position, velocity, and orientation in real time. This system is self-contained and does not rely on external signals like GPS, making it immune to electronic jamming. It continuously sends corrective commands to the propulsion system to ensure the missile stays on its pre-calculated suborbital path. Airframe. The airframe is the structural skeleton, often constructed from advanced aluminum-lithium alloys or composite materials. These materials provide a high strength-to-weight ratio, allowing the missile to withstand the immense G-forces during the initial boost phase while remaining light enough to maximize fuel efficiency and range. 2. The propulsion system, stages. Ballistic missiles utilize a multi-stage design to overcome gravity and reach the required velocities for long-range flight. First stage, solid rocket booster. This is the largest and most powerful section. It provides the initial thrust needed to lift the entire mass of the missile off the launch pad and clear the dense lower atmosphere. Second and third stages. Once the lower stages have depleted their fuel, they are discarded at the ** stage separation joints. This weight shedding allows the remaining, smaller motors to accelerate the lighter remaining vehicle to much higher speeds. Gimbal thrust nozzle. At the base of the first stage, the engine nozzle can pivot, gimbal, to change the direction of the exhaust. This provides the primary means of steering the missile during the boost phase, allowing for precise pitch and yaw adjustments. The flight profile. The flight of a ballistic missile is divided into 4 distinct phases. Launch, boost phase. The rocket motors ignite, and the missile is accelerated upward. This stage ends when the final booster burns out and the missile has reached its peak velocity. Midcourse phase, space. This is the longest part of the flight. The missile travels in a suborbital arc through the vacuum of space. In this phase, the missile is essentially a falling object following the laws of celestial mechanics, reaching its highest altitude, apogee. Re-entry phase. As gravity pulls the re-entry vehicle back toward Earth, it hits the upper atmosphere. The heat shield begins to glow as it handles the massive thermal energy generated by friction. Terminal phase, impact. The vehicle descends through the atmosphere at several times the speed of sound toward the designated target coordinates. 4. Classification by range. Missiles are categorized by the maximum distance they can travel, which determines their strategic use. SRBM short range less than 1,000 km MRBM, medium range 1,000 km to 3,000 km IRBM, intermediate range 3,000 km to 5,500 km. ICBM, intercontinental greater than 5,500 km, capable of traveling between continents.